In section 9.2, we're going to continue our study of area in the definite integral. And now we're going to look at area above a curve. Again, looking at the fundamental theorem of calculus. Suppose my function f of x is continuous on a defined closed interval. And this time the function is less than or equal to 0 for all points in the interval. Then the area bounded by the x-axis, the vertical lines x equals a and x equals b, and the function y equals f of x is given by this equation, which is the integral from a to b of a negative f of x dx. So we're asked to find the area bound by the x-axis, the line x equals 1, the line x equals 4, and the curve x squared minus 4x minus 5. Well, x equals 1 would be this vertical line right here. X equals 4 is this vertical line here. So we are looking for the area bound by this curve, the two vertical lines, and the x-axis. Now, since this area is completely below the x-axis, to find the total area, it's going to be the integral from 1 to 4 of the negative of x squared minus 4x minus 5 dx. So this will be the integral from 1 to 4. If I distribute the negative sign, I get that. And now if I integrate, I'm going to get negative x cubed over 3 plus 2x squared plus 5x going from 1 to 4. So now I'm going to plug in my upper limit and be careful that negative is not really part of the cube, it's out front. So here's my upper limit minus the lower limit. While putting a 1 in really doesn't affect anything, so it just becomes negative 1/3 plus 2 plus 5. Okay, doing a little bit of algebra here. 4 cubed is 64, and you times it by the negative, and you get negative 64 over 3. Plus 4 squared is 16, times 2 is 32, plus 20. If I distribute the negative sign, I get plus 1/3 minus 2 minus 5. So if I clean this all up, negative 64 over 3 plus 1/3 is negative 63 divided by 3. And that is going to be negative 21. So that gets rid of the thirds. And then I have 32 and 20. Take away 7. It's going to be 45. So negative 21 plus 45 works out to be an area of 24. So there's the answer to example number 1. Okay, in example number 2, we want to find the total area trapped by the x-axis and the curve. Well, notice this is a cubic polynomial, and it is going on forever in both directions. So the area trapped between the function and the x-axis is this area here. And we'll do this one in red, this area down here. So you notice part of the area is above the x-axis, and part of the area is below the x-axis. So to find the total area, we're going to have to break this up into two parts. We're going to have to look for the area from this point right here to this point here, and then the negative area from this point here to this point there. And reading off the graph, and if we were to factor our equation and solve for x, we do get the values. That's 3, this is 0, and this is negative 2. So in part A, I want to find the integral of my function, x cubed minus x squared minus 6x dx, going from negative 2 to 0. And that area is going to be positive because it's above the x-axis. And you're going to add to it the area from 0 to 3 of the negative of my function, x cubed minus x squared minus 6x. And the reason we have to put the negative up front here is because the graph is completely below the x-axis from 0 to 3. So now let's evaluate this. So this is going to be x to the 4 over 4 minus x cubed over 3 minus 3x squared, going from negative 2 to 0, plus the integral of, I'm going to integrate and distribute the negative, so it's negative x 4 over 4 plus x cubed over 3 plus 3x squared. And I guess if I do that, I don't need my integral sign. And that integral is being evaluated from 0 to 3. So obviously plugging a 0 in for here is going to make the first part 0 minus. Now putting a negative 2 in, this is going to be negative 2 to the 4th power over 4 minus negative 2 cubed over 3 minus 3 times negative 2 squared plus, now I'm going to plug in my upper limit in my second integral, which is going to be the negative of 3 to the 4th over 4 plus 3 cubed over 3 plus 3 times 3 squared. And minusing the lower limit, plugging in 0 is 0, so I'm not even going to show that portion of the calculation. So this ends up being 0, and this minus sign, very important, applies to everything in brackets here. So this is going to be 16 over 4, which is 4 times the negative will be negative 4. This part is going to be negative 8 over 3 times this negative is positive 8 over 3 times that negative is going to be negative 8 over 3. And I guess this bracket doesn't need to be here. So this is going to be negative 2 squared is 4 times negative 3 is negative 12 times the negative out front will become plus 12. And then looking at the last three terms here, this is going to be in negative 81 over 4. 3 cubed is 27 divided by 3 is 9. And 3 cubed is 27. So now, if we were to calculate all of this, okay, I'm going to get negative 4 minus 8 divided by 3 plus 12 minus 81 divided by 4 plus 9 and 27 is 36. And if you convert that to a fraction, you get 253 over 12 is the final answer. Okay, I pause you now, or encourage you to pause the video and give this last question a try on your own. All right, I'm hoping you had a chance to try this one. So if we take a look at this one, we want to find the total enclosed area enclosed by the x-axis, the curve x squared minus 3x, the vertical line x equals 1, which is right here, and the vertical line x equals 4, which is right here. This intersection point here is 3. So basically we have two parts. We have the part that is above the x-axis, which is going from 3 to 4. And we have the part below the x-axis, and that part is going from 2 to 3. So again, to find the net area here, we're going to have to, or the total area, we're going to have to integrate from 2 to 3 of the negative of x squared minus 3x dx. And then we're going to be adding the integral from 3 to 4 of x squared minus 3x dx. So I'm going to distribute and integrate at the same time for the first one here. So it's going to be negative x cubed over 3 plus 3x squared over 2, and that's going from 2 to 3, plus this is going to be x cubed over 3 minus 3x squared over 2, going from 3 to 4. Now plugging in a 3, I get the negative of 3 cubed over 3 plus 3 times 3 squared over 2. That's my upper limit minus Plugging a 2 in, I get the negative of 2 cubed over 3 plus 3 times 2 squared over 2. So there is the first part. So all of this part evaluated is there. And then I'm adding to this the second part. So if I plug a 4 in, it's 4 cubed over 3 minus 3 times 4 squared over 2 minus, now I put a 3 in, so I get 3 cubed over 3 minus 3 times 3 squared over 2. So now evaluating this, I'm going to get negative 9 plus 27 over 2. This part here is negative 8/3 times the negative out front is positive 8/3. And this is going to be 3 times 4 is 12. 6 times the negative is negative 6. Plus 4 cubed is going to be 64 over 3. Minus 16 times 3 is 48. Divided by 2 is 24. And then this is going to be 27 over 3 is 9, and the minus becomes minus 9. And 3 squared, this is going to be minus 27 over 2 times the minus is plus 27 over 2. And now we're just going to evaluate the final answer. So negative 9 plus 27 divided by 2 plus 8 divided by 3 minus 6 plus 64 divided by 3 minus 24 minus 9 is minus 33 plus 27 divided by 2. And this final answer works out to be 3. Okay, so that concludes section 9.2, area above a curve. So there's some questions for you to try in section 9.2. Again, give those a try and we'll look at them in class.